This is the second part of the video series discussing about organic isomers. Today I am going to discuss the isomers with heteroatom. Let us start with oxygen. The formula is C2H6 and O. So I am going to expand that. CH3, CH2, OH. Now whenever we see oxygen atom, there can be more than one option in terms of functionality. It can be alcohol, aldehyde, ketone, ether, like that. But if it is a ketone or aldehyde, then there should be an unsaturation. In this compound, we cannot see any unsaturation. Therefore, we can determine only alcohol and ether are possible. Now, when I check the chain of this organic molecule, we cannot see any changes in the chain because there are limited number of carbon atoms. Also, I cannot change the position of OH because it will result the same. For example, if I put OH here, then it look like different. But if we count, OH is connected to carbon number 1 and methyl. Here also OH is connected to carbon number 1 and methyl. Because according to the IUPAC nomenclature, we should use the least number. That means that we have to start the counting on the carbon atom to which the functional group is attached. Then we have to go to the remaining option. I am going to change the position of the oxygen atom in this way. Then it result an ether. This is going to be ether and this is going to be alcohol. Now this is the second example I am going to discuss. It has 3 carbon atoms, 8 hydrogen and 1 oxygen. As mentioned earlier, I am looking for alcohol again because this is also saturated compound. If you can remember the previous video, I have mentioned that when there are 3 carbon atom chain, we can make a chain isomerism. Then I am going to make that one here. It resolves this. We can count whether this is correct. 3 carbons, 1, 2, 3, 8 hydrogen, 6, 7, 8, and 1 oxygen atom. Now this looks like a difference in the chain. Now I am going to do the same structure in little bit different way. So this is that. Then I can see these two are same and the position of the OH group has also changed. Now I am going to name this. I am going to put 1 here, 2, 3. Then I can write this as 2 propanol. This one, 1, 2, 3. Again, this one can be written as 2 propanol. This one is a normal chain alcohol. Then I can write as N propanol. So the specific thing is these two compounds has changes in the chain as well as the position of the OH group. So it is important example. Now I am going to change the position of the oxygen atom. It will resolve this. This is going to be ether. I cannot change the oxygen further because it will resolve the same. So no point of changing the oxygen atom further. This is going to be methyl ethyl ether. Let us do this example also. It has 4 carbon atoms, 10 hydrogen atoms and 1 oxygen atom. Obviously, this should have more isomers because it has more carbon and hydrogen. I am going to change the methyl group of the chain. I will remove one of the methyl group and connect to second carbon. This one. I can check whether this is correct. 1, 2, 3, 4 carbon atoms, 3, 6, 7, 9, 10, 10 hydrogen atoms and 1 oxygen atom. Now I am going to change this methyl group to here to see whether it will resolve new isomer. It resolved a new one, but also it is an example to positional isomer as in the previous case because you can see OH is connected to the second carbon atom. Now what I am going to do is, you can see this is secondary alcohol because the carbon atom to which OH is connected has 2 alkyl groups, methyl and ethyl. Now I can convert this to tertiary alcohol. I am going to remove this methyl group and put here. Now it became a tertiary alcohol because the carbon atom to which OH is attached has 3 methyl groups. So it is a tertiary alcohol. Now after this point, we cannot do any changes on the main chain as well as the position of the OH group. Then we can move into the functional group isomerism. That means I am going to change the position of the oxygen atom in this chain. Now I am going to change the oxygen atom. This is the first one. I can change another one. This is the thing I can do. I cannot change another one because it will result the same. These two are going to be ethers. This is alcohol. Now this is how we made functional group isomerism where it is possible. But mind that whenever the number of carbon atoms and hydrogens are increasing, the possibility of isomers are also getting increased. So we have to be careful to not to miss any isomer and also not to create same isomer because they can cheat your eyes